to solve differentiation using the concept of equation of tangent and normal. So equation of tangent and normal is an aspect under application of differentiation. So first, what do we need to know under the application of differentiation? So under the equation of tangent and normal. So first, note the following. Recall that the gradient slash slope of a straight line. Recall that the gradient slash slope of a straight line M. I said recall that the grade slash slope of a straight line M is given by the y over the x being equal to M, right? So I said given slope slash what the gradient. Recall from our normal concept of physics. If I'm having a graph in this manner, right, such that my graph, let's say, has an inclined line this way, and I have my slope in this format. So here becomes my change in y, here becomes change in x. Of course, my slope here becomes change in y over change in x, right? Which is the same thing as what the dy over the x is now equal to what? M. Now, in other words, if I have, for instance, if I have a Cartesian coordinate, perhaps if I have y-axis and x-axis, if I pick a point here, this point we have two values. So this point will have a x value, and this point will have a y value. So in other words, if I'm given, if I'm going to find the slope of a graph, I know that the formula is what y2 minus y1 or what x2 minus x1. In other words, I apply this concept here. I'm saying that the y over the x is the same as what? Changing y by changing x. Of course, I'll have that y2 minus y1 for this guy all over x2 minus x1 for this man here being equal to n. Of course, I have an invisible one here. So that multiply, I'll have that y2 minus y1 is equal to m into x2 minus x1. Again. So from here, call this m1 please. Where m1 is called the equation of the tangent perhaps. So it's called equation of tangent, right? So where m1 is for tangent b. So in other words, if I'm going to find the equation of tangent of a given question, my formula goes below, right? So y2 minus y1 is equal to m1 into x2 minus x1 right here. So of course, from what we know that from the equation of a straight line, we know that y is equal to what? Mx plus c. This is the general form of the equation of a straight line. So if I'm having two values of y and two values of x, I'll have that y2 minus y1 is equal to m into x2 minus x1 next to plus c. But in this case, we're not considering c. C is called intercept. So I will ignore c and ignore c. So what I'm having here is simply the equation of tangent that I'm having here. So note that the equation of tangent has what we call m1. So m1 is simply what? The equation of what? Tangent. So y2 minus y1 is equal to m1 into x2 minus x1. So we are here. Also note that the gradient of the normal is m2. So from here, note that we know we have gotten tangent. Let's now discuss about normal. What's normal? Note that the equation of a normal is called m2, right? And m2 is simply the negative inverse of m1. So note that to get m2 is what? Not m1. We said m1 is simply what? Equation of tangent. Why m2 here? Simply what? Equation of normal. m2 is the equation of normal, right? So m2 is simply the equation of normal. So in other words, my M2 here becomes y2 minus y1 from this concept here is now equal to, this is M1. Here becomes what? M2, to signify that we are dealing with what? The equation of normal. So M2 is simply what? The equation of normal. So into x2 minus x1. So in other words, my two equations are as follows. Number one is this, and number two is this. So the idea is that when I'm going to find the equation of tangent and normal of a given curve, my formula I'm applying is what? Is y2 minus y1 is equal to m1 into x2 minus x1. This for tangent, please. For normal, I have that y2 minus y1 is equal to m2 into x2 minus x1. So note the following equation for each of these following. Alright, so let's take some problem. Example 1, under this, to understand the concept. Example 1. Alright, let's take some problem under this. But for that, I can also call this one here slope of tangent, or perhaps slope of normal face. So this man here is actually expressing the equation, right? So I can call M2 my equation of normal, or perhaps the slope or gradient of normal, while M1 is simply the slope or gradient of my tangent here. Example 1, the question says, find the equation of the tangent and normal. Find the equation of the tangent and normal to the curve. Find the equation of the tangent and normal to the curve y is equal to 2x cubed minus x squared plus 3x plus 1. So at 1, 0. So I'm given that find the equation of tangent and normal to the curve this, right, at 1 and 0. First things first, I want to know something. For this 1 and 0, this is actually what my coordinates is said. So this 1 is for x-axis, and this 0 here is for what the y-axis. So I'm given this expression. I'm going to find the equation of what? Normal, perhaps tangent, and what the normal. So the idea is that your first task is what? Look for the equation of tangent first before normal. So for normal view, I'm going to look for what? The equation of tangent first before normal. So what is first? From this concept here, my first task is to get what? The y by the x value. Of course, before I proceed, we are told that this is a curve, right? So this is a cubic equation. Let me show you something, please. If I have a linear equation, for instance, if I have that y is equal to ax plus b, this is what? A linear equation. The graph that this man here will produce is called a straight line graph. I have something of this nature. So if I have that y is equal to ax squared plus bx plus c, this is what? A correct equation. So my curve here becomes a what? A parabolic curve in nature, right? Something of this nature, right? So this is a graphic as what? A parabolic, a U shape, right? So if I have a cubic equation, let's say ax cubed plus bx squared plus cx plus d. This is what? A cubic equation. So the graph for this one becomes perhaps a two-curve graph in this manner. So the idea is that whenever you have a cube equation, I will have two curves in my graph. Whenever I have a quadratic equation, I will have what? A U shape or perhaps a parabolic shape in nature. And finally, if I have a linear equation, I will have a straight line graph. So for this one now, I'm having a cubic equation. Of course, I will have what? Two curves from this concept here, please. So First task, get the y over the x value. From here, the y over the x here is equal to, of course, I'm reducing y with what? Respect to x. If I reduce 2x squared, all I have is, I have 6x squared. Next up, minus 2x plus 3. Of course, this is my what? My value for the y over the x. Alright, from here please. From here, look at this. We said your first task is what? Differentiate this man. After doing this man, I have this, right? So because I said that the y over the x is equal to m. So my first task is let's get m. So in other words, for these two coordinates here, I have x to be 1 here and y to be 0. Of course, at x equal to 1, what will be the answer for y over the x? So we said the y over the x is now equal to, from here, anywhere I see x, I'll put 1. I'll have that 6 into this x, put 1, all squared, minus 2 into 1, plus 3. So hence, my value becomes 6 minus 2 plus 3, please. What must I here? Answer here. The y over the x here is equal to what there? 7. Of course, we said that the y over the x is something as what? M, which is as what? Which is equal to what? 7. So in other words, my m1 here, so therefore, my m1 is equal to what? 7. So your first what? Get the value for the y over the x. Substitute x as 1 to have the real value of m1. Of course, from here now, I can easily get my equation of tangent. So recall that we said from equation of tangent, we said that y minus y1 is equal to m1 into x minus x1. I have this. So y minus y1 is equal to m1 into x minus x1. Of course, my y1 is simply this man here. This the value for y1. This is what? x1. Of course, y1 is 0 and my x1 here is what? 1. In other words, put the value of this coordinate here. So I'll have that y minus y1. What's y1? I have 0. So minus 0 is equal to m1. Check. m1 is 7. So I have 7 here into x minus x1. Of course, x1 is 1 here. So I have 1 at this section here. So y minus 0 is what? Is y. So I have y being equal to, expand this bracket, please. So y 7x is 7x minus 7 minus 1 is 7. Of course, this becomes the equation of tangent. Whenever you call something equation, in mathematics, whenever you see a mathematical expression, how do you know that mathematical expression is an equation? It's because of what? The equal to sign. So whenever an equal to is in between mathematics, we call it what? An equation. So of course, we are going to find the equation of what? Tangent. Of course, I'm going to express this what? In terms of equal to. So y is now equal to 7x minus 7. Of course, if I write 7 out here, is it correct? So there's the equation of what? The tangent. So now let's not get the equation of normal. We said for equation of normal, we said that, so recall that we said m2 is simply what? Slope or rate of what? Normal. We said m2 is what? The negative inverse of m1. So my task says what? Get the value for m2. So when I know my m2, I can easily put the value here to find the equation of what? Normal. So from here, my m2 is now equal to minus 1 over 7. m1 is what? 7 here. So put in 7 here. So my value for m2 becomes minus 1 over 7. Alright, from here please, look up. From here, I'll have that from here now I've gotten my M2. So let's get the equation of what? Of normal. So from here, for equation of normal, we have that y minus y1 is equal to m2 into x minus what then? X1. I am here. Of course, I'm using the same coordinate system. So x1 is 1, y1 is 1. And this concept is the same thing. Alright, from here, please look up. From here, I'll have that y, this is y. So minus y1, of course, y1 is 0, so I have 0 here. Now equal to m2. What's m2? m2 is what? Minus 1 over 7 into x. I have x minus x1. Of course, x1 is what then? 1. I have 1 here. Of course, if I work on this, y minus 0 becomes y. Is now equal to minus 1 over 7 all into x minus 1. Yes. Of course, I will multiply. I'll have that 7y is now equal to minus 1x minus 1. Of course, if I expand this bracket here, I'll put on 7y to be equal in value to minus 1 times x is what? Minus x. Minus 1 is what? Plus 1. Of course, I can't express my negative. Of course, I will arrange this such that my 7y will be equal to, look at the positive term first. So I have 1 next up minus x. So this becomes the equation of my normal as my final answer. So this is how to solve problem involving the equation of tangent and normal under application of differentiation.